Today's section 1.4 involves representing functions as graphs. In section 1.3, we took a look at mapping diagrams, tables, and rules to represent those as functions. And today we're also going to look at representing functions as graphs. As we discussed in section 1.3, the input represents the x values along, we might also call this the domain, and the output represents the y values, in which we would call the range. So to represent these as ordered pairs, I could, first of all, remember x always comes before y, just like in the alphabet. I could write my x coordinates and then fill in the corresponding y coordinates. All right, so these match up just like they do in the table. And then to create a graph, I have to look at where 3 is on the x-axis. So you're really always starting at the origin, 0, 0. If I go over 3 units for x equals 3, but then up 6 units for y equals 6, that would be my first point. The second point, I would go over 1 unit, up 4 units, so that my point is right here. And then for the third point, over 5 units, up 8 units, and I'd have a point at 5, 8. Now, obviously, I don't need these lines. That was just to show you kind of following my path to those points. All right. Next, we're asked to graph the function y equals 1/4 x with the domain 0, 4, 8, and 12. To do that, I can first create a table if I'd like. I have my inputs and my outputs. I'm going to choose just a couple values. Oh, sorry. Our domain is already given to us. So our x values are 0, 4, 8, 12. Just like in section 1.3, I can substitute each of these values into my equation or rule to figure out the following outputs. So y equals 1/4 times 0. Well, that just gives us an output of 0. When the input is 4, the output is 1, 1/4 times 4. When the input is 8, the output is 2. And when the input is 12, the output is 3. So I can go ahead and graph each of those points. Right here is 0, 0. 4, 1, I'd go over 4, up 1 unit. 8, 2, over 8, up 2. And for 12, 3, over 12, up 3 units. And that's all I'd need to do. In this next example, the table below shows the average score M on the mathematics section of the Terra Nova for BRK from 2006 to 2011 as a function of time t in years since 2006, and we want to graph the function. So even though we're being given variables other than x and y, we can still graph this. We just have to recognize the independent variable versus the dependent variable. Now, because we're told this is a function of time t, that tells us t is the independent, so that is our x variable, meaning y is the average score or variable m. Now, we have to keep in mind what the scale we want to make the graph. If you notice, the y values are much higher. However, the x values are lower, so I could keep that as I normally would. So for my x-axis, I've scaled it by 1s, but I've only filled in the odd numbers due to the space that I have. But as you can see, we'd have 0, 1, 2, 3, 4, 5, 6, 7. The most important part here is whatever scale you choose for a specific axis, you have to use for the entire axis. Now, because I have limited space, but much higher numbers for the y-axis, I'm going to draw what we call a break in the axis to go to my starting number. So I might have this as 0, but then when I create my break on my axis, it's going to scale up to 60, and I'm going to scale each line by 2s. And actually, I'm going to start this at 66. So even though I'm scaling by 2s, I'm going to write every other just again because of space. So that's 70. This next one will be 72. Then I have 74, 76, 78, 80, 82, 84, 86, and so on. Sorry, the writing is a little hard to understand at times. But we'll go ahead and plot our points. Our first point is at 0, 68, so that's right here on the y-axis. Next point, 173, so over 1, and then 73 would be about right there. 274, 377, 478, and 582. Next, we are asked to make a rule for the function represented by the following graph and to identify the domain and the range of the function. So I would suggest creating a table of inputs and outputs based off the points you see in the graph. So this first point, would be 1, 1. The second point, 2, 5. Then we have 3, 5. Sorry, it was 2, 3. And then 3, 5. The next point, 4, 7. And lastly, we have 6, 9. So something you might notice here, the outputs are increasing by 2 units each time. So looking at this, it's always adding by 2 as the inputs are only increasing by 1 unit. All right, so that might tell us something. Now, if we look at just our 4 major operations, there's no single operation that holds true every time. So for example, if I try addition, well, 1 plus 0 equals 1, but then 2 plus 0 does not equal 3, so it's not addition. Multiplication doesn't work, subtraction doesn't work, and division doesn't work by themselves. So this tells us it must be a combination of operations. Well, this plus 2 gives us a hint. When you're adding 2 repeatedly, that's the same as multiplying by 2 by some number of times. So we could think 1 times 2 equals 2, but our output is 1, so we'd have to subtract 1. So then if we try this with our next set, 2 times 2 minus 1 does give us 3. And then our next pair, 3 times 2 minus 1 does equal 5. And as we can see, that works for the rest of them. So our rule itself, the numbers that are changing are the outputs and the inputs. But then multiplying by 2 and subtracting 1 are staying the same. So we might say y equals 2 times the input minus 1. And that is our rule. Lastly, our domain is simply all of the values of x, and our range is all of the values of y. Now I'd like you to try for yourself by graphing y equals 3x minus 2 with the following domain, and then writing a rule for the function of the second graph. So pause the video now before revealing the answers. So for number 1, we get the following corresponding outputs: -2, 1, 4, 7, and 10. For that first point, 0, -2, you'll see that it does fall a little off the graph, so you can kind of estimate where that is. For number 2, the rule would be y equals 1/2 x plus 2. And the biggest key here is when 0 is our x, 2 is our y. So we know even if we multiply 0 by something, it will still be 0. So we would need to add 2 for this to work out.